Hi guys, welcome to PyMath. In today's video, we're going to be solving a problem that says, what is the number of zeros at the end of 100 factorial? And we're going to be using the same method that we used in yesterday's video. So let's get started. Before we start solving this problem, let's review the exponent of primes in n factorial. This is the method we used yesterday, and is basically a method to find the exponent of any prime in any n factorial. And this is the method where p is the prime and the exponent of the prime in n factorial is n over p plus n over p squared plus n over p cubed all the way up until plus n over p to the power of s, where s is the largest positive integer such that p to the power of s is less than 1, but p to the power of s plus 1 is greater than 1. And if you notice, we have square brackets around each of the expressions. And that's because this is a largest integer functions, which means decimals and remainders will be ignored. For example, if we have 100 over 98, and that's the largest integer function, we'll have an answer of 1 with a remainder of 2. We just discard the remainder 2 and keep the answer 1. So that's what the largest integer function is. Let's solve the problem now. What is the number of zeros at the end of 100 factorial? Let's expand 100 factorial in terms of prime factors, okay? That would be 2 to the power of a times 3 to the power of b times 5 to the power of c times 7 to the power of d times 11 to the power of e times 13 to the power of f. It would look something like that, okay? And now we need to determine which numbers contribute to the zeros. If you haven't figured it out already, they are 2 and 5. So we need to focus on the exponents of 2, which in this scenario would be a, and 5, which in this scenario would be c. Okay? Let's get to finding exponents of primes 2 and 5, which will be the answer to this problem. And we're going to use the method I discussed earlier. So if we do 2 first, we have to determine the s value. 2 to the power of 6 is 64, but 2 to the power of 7 is 128. So thus, s is 6, because 2 to the power of 6 is less than 100, but 2 to the power of 7 is greater than 100. So s is 6, as I said. So that gives us 100 over 2 plus 100 over 2 squared plus 100 over 2 cubed plus 100 over 2 to the power of 4 plus 100 over 2 to the power of 5 plus 100 over 2 to the power of 6. When we plug all the values we have into the method. And since this is a largest integer function, we get the values 50 plus 25 plus 12 plus 6 plus 3 plus 1, which gives us 97. So thus, the exponent of 2 in 100 factorial will be 97. Let's solve for 5 now. For 5, s would be 2, because 5 squared is 25, but 5 cubed is 125. As we know, 25 is less than 100, but 125 is greater than 100. So s would be 2. When we sub all the values in, we get 100 over 5 plus 100 over 5 squared, which gives us 20 plus 4, which is 24. Thus, the exponent of 5 in 100 factorial will be 24. So we have 2 to the power of 97 and 5 to the power of 24. And those are the only two numbers that will contribute to the amount of zeros in 100 factorial. Now, we can only take 24 of the 2's because there are only 24 5's. The rest of the 2's aren't going to do anything. So the only 2's we can take are 24 of the 2's, the first 24. So that gives us 2 to the power of 24 times 5 to the power of 24. And those are the only two primes that will contribute to the zeros. So thus, there are 24 zeros in 100 factorial, and that would be the answer. Thank you guys for watching, and I will see you next time.